Okay guys, so today we're going to look at operators. Operators are the symbols that we use to control what a relationship does, or what a statement does, or what a logical structure does. They compare two things. Sometimes they compare values. Sometimes they modify values. We can use arithmetic operators to change value by making an addition or subtraction, multiplication, etc. We could use the assignment operator, the equal sign, to determine what value a variable has. We could say, okay, A is equal to 5, or B is equal to a string, or whatever. We use comparison operators to compare two variables or two values to see if they're the same or if they're different, if one's bigger than the other, etc. We can use logical operators to do logic statements, which we'll talk about, and, or, and not. Basically, and means true if both statements are true, or means one of them has to be true, and not gives us exactly the opposite. We can use identity operators, is or is not. We'll talk about those a little bit later on. When we're creating sets or arrays or things, we use the in and not in operator to see if an object is a member of one of those things. And then bitwise operators, we use the ampersand sign, the pipe stem sign, the up arrow, the tilde, two greater than or two less than signs, basically to shift bits around. That's the and, or, XOR, not, and then we can fill in zeros one way or the other. We won't use those a lot right now because we're not going to do a lot of bit operations until maybe way toward the end. But they're at least there, and Python is well able to handle bit operations. So right now, let's go ahead and go to the desktop. All right, here we are. Let's go ahead and look at, first of all, let's set up our environment. We've got our Notepad++ is open, and we're going to go ahead and make sure that we have it saved the right thing. This is going to be Python exercise 10, so we're going to save it as Python exercise 10. Yeah, we're going to get rid of that and put it back in just to make sure it's there. And then we're going to head up over to our command prompt, and we're going to open that. Let's change over to our C:\Python code and make sure that we have 10 in there. We do. There's exercise 10, so we're good to go. Alright, so the first we're going to look at are some arithmetic operators. Basically, you should be familiar with all those. Essentially, addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. The last two you may not be as familiar with, but we're going to go ahead and create a couple of variables here. Say A is equal to 5, and B is equal to 3. And we're going to say, first off, use some comments here. We're going to use the addition operator. We're going to say C is equal to A plus B. And then we're going to B, and then we're going to print C. And if you look at that, it's pretty apparent that C is going to end up being 8, because we're going to say 5 plus 3 is 8. And so now, let's set up a subtraction. And remember, we're using comments. This is a good way to outline or to diagram your code. Reminds you what you're supposed to be doing. So we're going to use a set of comments to outline which of the operators we're working with. This one's going to be subtraction. We're going to say C is equal to A minus B. And then we're going to print C again. I got to quit hitting that. All right, and multiplication, which the multiplication sign in Python is the asterisk, as it is in most other computer languages. C is equal to A times B. Insists on doing that, but it needs to stop. And then print it out. And then finally division. some other ones that we're going to look at. Modulus. Essentially, modulus returns the remainder of a division problem. So if I say C, and the symbol, by the way, is the percent sign. So if I say A modulus B, then it's going to divide 5 by 3, but it's not going to give me the whole answer. It's just going to be the remainder. So 3 will go into 5 one time with 0.2 left over. Or hang on, 3 goes into 5 one time, and then that gives us, okay, 1.0, so 1.3, essentially 1 1/3. That makes sense. Anyway, we'll see in just a moment if my estimation powers are correct at all. And then exponentiation basically is raising something to an exponent. Exponentiation, and we do that with 2 asterisks, like 2 multiplication symbols. So we're going to say C is equal to A to the bth power, print C, and then floor division, which basically just returns the integer. When you're floor dividing, it rounds whatever answer you get down to the next lowest integer. So it rounds it down, which is kind of weird, but that is what it does. Floor division. C, whoops, and we do that with 2 division symbols, A divided by B. That's floor division. Print C. All right, so what we have here, I think, if I've spelled everything correctly, is all of our arithmetic operators that we're going to look at. So let's go ahead and save, and let's run. _10.py, and sure enough. All right, so let's analyze our code, compare it to our answers. First of all, in addition, we said C was equal to A plus B. We added 5 plus 3, and that gave us 8, which we're good there. Also, with subtraction, we subtracted 5 minus 3, and that left us with 2, which we're good there. In multiplication, we multiplied 5 times 3, which gave us 15, and so we're good there. In division, looks like I was wrong. It's not 1 1/3, it's 1 2/3. So we ended up with 1.666666, but you notice it rounded. It did not continue on the decimal place forever. It rounded, let's see, 3, 4, 5, 6, 7, 8, 9. Oh, wait, 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 places is what Python will round to when you do a regular division. You divide 2 integers and you get a remainder like that, you're going to get 16 places. Okay, so for modulus, what we do is we divide 5 by 3. 3 will go into 5 one time with a remainder of 2, and that is what we got. It takes the it gives us the remainder. I guess you'd call it the signed remainder, Euclidean division. That is what we get. We divide 5 by 3, goes in one time, it leaves us 2 as the remainder, and that's what we get. Why would you use a modulus, do you suppose? One of the most common uses is determining if a number is even or odd. A lot of times, program will need you to determine if a number is even or odd. So you can take that number and divide it by 2 modulus. So you modulus it by 2. And what happens is if the remainder is 0, that means that the number was evenly divisible by 2, which means it's an even number. If there is any kind of remainder, what you would do with your if statement is say if the remainder is not equal to 0, then this is an odd number. But if it's equal to 0, then it's an even number. So that's one place you would use a modulus. Exponentiation, we said 5 To the power of 3, we do 5. First power is 5, squared is 25, cubed is 125, and that's what we got. And then finally, floor division, that gives us the integer. It rounds it down, and so a while ago we said 5 divided by 3 was 1 with 2 left over, so it rounds that down 1 2/5, rounds down to just 1, and so that is in fact what we got. So that is the arithmetic operators, at least all the ones that we're going to look at. That's the most common ones. Anything else for arithmetic operators that you see is going to be more complicated than that. All right, so having said that, let's go ahead and look at assignment operators. Assignment means I'm declaring something to have a value. I'm using equal sign, for example. I can say x is equal to 5, and then I know that the variable x has a value of 5. I can increment, I can decrement, I can multi-increment, multi-decrement. I can, there's all sorts of things that I can do. So let's go ahead and set that up. We're just going to do a few of these. We're not going to do, there's a lot of different things that we can do with assignment operators, but we're just going to look at the main ones first. So the main one obviously is going to be the equal sign. It's going to be x is equal to 5. Oops, and then we're going to print x. Oh, pardon me. We have a is equal to 5. Nope, now we're going to say a is equal to 4. Print a. And then we're going to use the increment. That means to add a value to that. So we're going to say a plus equal 2. I need to put my comment in there. Increment. And then we're going to print a. We're going to decrement. And we're going to say a minus equals 2 or 3. Print a. Okay. And then we're going to, let's do the exponentiation. These amount to are shortcut ways to write the equations. So I'm going to say a dot dot equals. So this should give me whatever a is at this point squared. Let's see, are there any other ones that I wish to do? You know what, I think I'm going to stop right there because the rest of them are really esoteric and not as useful. So let's go ahead and do these. All right, so what do we got the first time? We said that x was equal to 4. We just assigned it the value of 4, and there it is. The next time, we said increment x plus equal 2. What that means is x, or a is equal to a plus 2. So it increments a by 2, or whatever number we put here. And so 4 plus 2 is 6. We decrement basically is the same thing. We divide, we subtract. Wow, having trouble today. We subtract whatever value this is. This is like saying a is equal to a minus 3. And so 6 minus 3 is 3, which it did. And then finally, we're going to exponent. We're going to raise a, which is 3 to the power of 2. 3 times 3 is 9, and that is in fact what we got. So far, all of our assignment operators are working as well. And basically, they're just ways to assign new values to a variable based on what we choose to do here. All right, so now the next one, we're going to look at our comparison. Now we can assign values. We need to compare them and see how they compare to each other. So are they equal? Are they not equal? Are they greater than, less than, greater and equal to, less than and equal to, which or what? So first of all, we're going to go equal. so we're going to say, oh, by the way, I need to tell you, this returns a Boolean. If they are in fact equal, it'll return true. If they are not equal, it will return false. Most of these, or all these comparison operators return a value of true or false. They return a Boolean. So we're going to print A is equal to B, and that will compare A and B, and it will give us a true or false based on if that's correct or not. Same thing here, not equal. And we're going to print, oops, A, and we use the exclamation point and the equal sign to say not equal to. So that will give us true or false based on whether A and B are not equal. Greater than, we're going to print A greater than B. And that will, if A is greater than B, it will say true. If it's not, it'll say false. Same with less than. A less than B. Based on that relationship, it'll print true or false. And then greater than or equal to and less than or equal to, basically the same thing. Oops. Have these. Let's go ahead and run them. Let's see what we get. P1. All right, so first one, we said A, is it equal to B? And no, it's not. One's 5 and one's 3, so it returned false. And we said A is not equal to B. That was the question, and it returned true because 5 is not equal to 3. The next one, A is greater than B. Well, that returned true, obviously, because 5 is greater than 3. The next one being A less than B, that returned false because, no, 5 is not less than 3. The next one was greater than or equal to. That one returns true if either one is greater than the other or they're both equal. Well, this one returned true because 5 is still greater than 3. And the converse of that, A is less than or equal to B, returned false because 5 is neither less than nor equal to B. And so all those things worked out exactly as we expected. So at this point, I think we're going to go ahead and stop because we're not going to use the identity operator or the membership operators yet. We're not going to start dealing with sets or anything like that, or anything containers like that. So we're going to go ahead and stop at this point, I think, and we will continue on with the other operators when we get to those things. Okay, guys, hope this was helpful, and I hope you weren't too terribly confused by my a little bit eclectic style. I'm going to say eclectic because that's a kind way to put it, but anyway, sorry it was a little disorganized today, but hopefully this will help. If you have any questions, if it is confusing, whatever, contact me via the Canvas inbox. I am reachable through there, and hopefully we'll see you in class. Have a good day, and